Our next speaker is Larry Smarr. He will talk about UCSD, the Big Data Freeway System.
So everybody's been talking about big data, and the question is, what are we going to do about it? The key is just to realize that the internet that we've spent 40 years building is engineered for megabyte-size objects. You guys are using gigabyte to terabyte, so 1,000 to 1,000,000 times the capability. That means we have to scale up the computing, the storage, the networking, the visualization by that amount. And this is from Mike Norman. That really gives us an idea with that infrastructure, which is what I'm going to talk about, how we can be the best in the country at this infrastructure. It's within our grasp now after a decade of investment, because we sit at the center of the world's best statewide and regional optical network, CNIC, which supplies the connection to all of the UCs, Cal States, the privates, and down to actually all 9,000 K through 12. 10 million Californians use it every day. San Diego, why are we going to be any better than anybody else in the state? Well, for one thing, we're going to be the first to get 100 gigabit, thanks to Mike Norman and Min Yao here with an NSF grant, the first to go from to 100,000 megabits per second as our gateway. That's already been linked into the Department of Energy national scale network and to the internet too. So now that means if we can get from our campus, we go through the state, we can get nationally, but for the last 10 years, we've been building something called the Global Lambda Integrated Facility. All those lines you see are submarine cables that go at 10,000 megabits a second all over the world to innovation centers in Asia, Europe, that are all linked together. And these people all come to the Qualcomm Institute once or twice a year. We are the global acknowledged leader of this entire global fiber optic network. And so, know it or not, we're at the point of the spear. Now, what's missing is that Phil Papadopoulos, who was the PI of this, I'm a co-PI, again, a classic San Diego Supercomputer Center Cal IT2 award, is how do we get from the campus gateway to all of the data generators on campus? Each one of these, that's the world we're in now, is supercomputers aren't the only thing that generates data, it's all the scientific instruments. We completely distributed them. We have plenty of bandwidth into the supercomputer center, but what about to the gene sequencers and the mass specs and everything else? That's what this lets us do. So there's a switch in Cal IT2, the first one in the country, that enables fiber optics to go to your lab, to your instrument. And then notice that we're at 120,000 megabits a second between that switch and SDSC. And what's in SDSC is some more of those switches that hook the Gordon supercomputer that Mike was the PI of, the only big data supercomputer NSF has funded in this country, and Data Oasis. Data Oasis, look at that, 128. Each of those that's how many 10 gigs per second. 128 times 10 gigabits per second. Is so that there's nowhere on Earth that has this kind of connectivity between this giant ocean of data and a computer capable of computing it. But what's coming even better next year, SDSC is getting for the rest of us, for all of the tail of people who use, logarithmically less and less data, this is going to be the only machine in the country to do that. So we're sitting on a gold mine, and what we've done is get the application leaders across the campus to come together and tell us what they needed. They were the ones that helped us win this proposal. So we've already lit up 80 gigabits, 80,000 megabits a second to the physics department, to the gateway across the country, across the ocean, to the CERN Large Hadron Collider. So that because they're a tier 2 center, which is one of the major data centers for the country, well, that means people have to get onto our campus, across our campus, and to their repository for that to be effective. Down at the Scripps Institution of Oceanography, we have the place that does the 50-year projections of climate change in this state. People are waking up. There's going to be some serious changes. Well, what do? They have to go to NCAR in Colorado and places and download the output of supercomputers that have done climate modeling. And they got to get it to their lab in a building at SIO. That's what we're putting in a fiber arc directly to their lab. Mark Ellisman has one of the most advanced microscopy centers in the country. He's the National Institute of Health Center for this. Well, now we've got these connections, that is a part of a mouse brain on our wall in the Qualcomm Institute from the instruments sitting down in the School of Medicine that are linked together now. They're going to go up to something like 80 gigabits a second. The Protein Data Bank. This is the longest funded NSF project I think there is. We have one here and in New Jersey, but there's a global, people are hitting this hundreds of times a second to download this data. Well, do we have the bandwidth? You can't run this over the campus network as this data exponential continues. You may for a while, but sooner or later that exponential is going to overwhelm the network. It needs a separate freeway. So think of the city of San Diego. The city streets are like the shared internet. Close all the freeways tomorrow. Just say, use the streets. How's that going to work? There's a reason we built the freeways. And that's because you got to get a lot of traffic from point A to point B without going through C, D, and F, and that's what we're building here. Kelly Fraser is going to talk next about the Institute for Genomic Medicine. I was just down there meeting with her on her core of Illumina Next Generation Gene Sequencers, the computational NIH Mass Spectrometry Center. These are all being connected to this switch, to SDSC, to the rest of the world. But it's the arts as well. Here we are having a jazz quartet between Irvine and San Diego, where half the instruments are in Irvine. And because they're over a 10 gigabit with no loss, they can do it in real time because the speed of light goes pretty quick between here and Irvine. And collaboration. So take that same idea. That's Chicago over there. They're looking at my guts, which is a 3D MRI that I've pulled up. I'm looking at them here. We've got high definition, which is going to 4K, linking us together. So we're just like in the same room examining all of this big data. And that's the kind of collaborative infrastructure. Now, this all is going on. We have had hundreds of millions of dollars of federal investment in this campus between the Supercomputer Center, LIT2, and these other things. But what have we harvested for ourselves? That's the small amount of money, but high amount of leadership and vision that this campus needs to have to say, let's get it done. Let's get it done this year. And then it's extensible. So as every new place comes along that has more data, give them their own separate pipe, separate from the shared internet, so that they live in this world 1,000 times faster than the shared internet. If we do that, winning grants will not be a problem, because that goes into the facility section of everybody who sends a grant in, regardless of where it is to or on what topic it is. Yeah, Peter.
Depositing data is one thing, but then to actually retrieve it and analyze it is a second thing. And right. You haven't really touched on that, because I think they need to be co-developed. And maybe I'm wrong on that, because you have a better insight into that. But what are your thoughts?
Well, so for instance, when you have a 10 gig, say, into your lab, which is one of the labs we'd love to link into, Gordon and Data Oasis are in your lab. I mean, it's the same speed as the backplane of a cluster. We're building essentially a cluster the size of the campus. So everywhere that you want to put data, retrieve data, compute on data, is at the speed of the backplane of a cluster. Now, we normally think a cluster is something you put over behind in a little cage somewhere. Think of the entire campus inside that backplane of the cluster with every move of data at the same speed as the backplane of the cluster. That's what this does today. Now, the software that has to be available, all the stuff, we have nowhere near the human talent that we need to not only do all the algorithmic work, but what we need is the people who come into your lab from SDSC, Qualcomm Institute, computer science, whatever, and say, we're going to camp out here for the next week, and we're going to get you all hooked up. We're going to put our little meters on everything, get you totally, then we're going to work with your grad students and your postdocs to get their software up on the system, and we're going to work that through until you're real happy and comfortable, and then we're going to go to the next place. We don't have that, but it wouldn't be that difficult to put it in place.
that we have real-time storage of everything we collected.
Right.
How do we connect with software to that data?
So one of the things we're developing is a big data server that's like just a normal PC that we've got, but with a lot of flash memory. It's essentially a node of Gordon. And then you plunk that down. I was just talking to Kelly this morning about this. You plunk that down in your lab, and you connect that to all of the computers that are running your other instruments, and then it's connected at like 40 gigabits a second to SDSC or the rest of the world or whatever. And that's an architecture that'll work in any lab, because you already got computers running each of the instruments. They're just not set up to run at this thing. So you have them send the data into this big guy. It might have a rotating, say, 50 or 100 terabyte disk, 10 terabytes of flash, multi-100 gigs of memory. It maybe cost $10,000. It's just like essentially a PC. Expensive PC. You just use it every day. San Diego, why are we going to be any better than anybody else in the state? Well, for one thing, we're going to be the first to get 100 gigabit, thanks to Mike Norman and Min Yao here with an NSF grant, the first to go from to 100,000.
Our next speaker is Larry Smarr. He will talk about UCSD, the Big Data Freeway System.
So everybody's been talking about big data, and the question is, what are we going to do about it? We sit at the center of the world's best statewide and regional optical network, CNIC, which supplies the connection to all of the UCs, Cal States, the privates, and down to actually all 9,000 K through 12, 10 million California. The key is just to realize that the internet that we've spent 40 years building is engineered for megabyte size objects. You guys are using gigabyte to terabyte, so 1,000 to 1,000,000 times the capability. That means we have to scale up the computing, the storage, the networking, the visualization by that amount. And this is from Mike Norman. That really gives us an idea with that infrastructure, which is what I'm going to talk about, how we can be the best in the country at this infrastructure, where it's within our grasp now, after a decade of investment, because